Okay, so we continue chapter induction machine ELE291 part 2. So in the previous video, we have already looked through the approximate equivalent circuit of induction motor. Okay, so next important part is the power flow. First is the equivalent circuit, then how you calculate the current, stator current. So the last important part is the power flow diagram. So power flow diagram. So how do we read this power flow diagram? So supposedly the any electrical machine, in this case our induction motor, needs to convert from P in to P out. So it's a motor. So motor means the output is P mechanical, rotating part on the rotor. So the input is P electrical. So in watt and in HP. Okay. So P in is the electrical power. P out is the mechanical power. Okay, some power has formulas. Also ada yang no formula provided, means you need to make use of this power flow diagram. So it's okay. So actually, any equipment we want to deliver 100% of input power into, want to deliver 100% input power to the load at the output side. In other words, we want to convert 100% of the electrical power into mechanical power. However, that does not happen for a real situation in practical. Okay, there are losses. Okay, so we want to deliver 100% from here to here, but then throughout the way, through the stator, through the core, through the rotor, you have a few losses. So the arrow downward are all the losses. The first loss is the PSCL. Okay, if you're not sure, it's not stated there. SCL is for stator copper loss. Okay, it's the losses dekat. Okay. Oh, I cannot padam anymore. So losses here, stator copper loss. So that's why the formula is I2 phase squared times R1. Okay. Okay, and then after the current go through the stator, also you have magnetizing branch. Okay. So on the magnetizing branch, you have core resistance. So core also becomes heated. So you have heat loss. So core also has core loss. Okay, but as you can see, there is no formula. So for those who, without formula, if it's not given, then you may assume it as 0. That is the first one. Okay. Okay, so the third loss is the PRCL. RCL stands for rotor copper loss. Losses where? Losses on the rotor resistance, that is R2, not R2 over S, R2. Okay, so although we have already in the circuit, it is combined with S to become air gap resistance. However, the question may ask you for rotor copper loss. So because rotor is located at the output side, so the current that you will be using to calculate the loss is also I2 phase. So that's why the formula is I2 phase as well. I2 phase squared times R2. 1 minute. Okay, so I forgot to tell you. There are a few corrections. Well, first one, the previous slide you have here another formula, and also you have 3 in front. But that one we need to remove because for ELE291 new syllabus, it is not covered for 3 phase. So the formula for P in becomes only this. and also I forgot to erase this 3. 3 is not there if you're calculating for single phase. So please delete the first formula, the 3 in front here, 3 in front here, 3 in front here. So because we are only dealing with single phase. Okay, my apology. Okay, so I2 phase squared R2. So the other formula for PRCL is also S times PI gap. S is the slip lah. PI gap. So what is PI gap? I will explain later. So the fourth loss is the mechanical loss. Okay, throughout the output, this is in, this is out, right? So throughout the output side, that is where you have your mechanical loss, right? Your mechanical loss in on the rotor. Input electrical, enter in stator. So when you have rotating part on the output side, okay, so of course you'll be having mechanical loss. For example, okay, mechanical loss can be either these two, rotational loss or friction and windage loss. Rotational or friction and windage loss. Okay. This one also no formula, so if it's not given, so you may assume as 0. Number 2. This is number 1. If it's not given, you may assume 0. And also the last one, P stray loss or P miscellaneous loss. Okay, if it's not given, then you may assume 0 as well. Okay, for that. So the description of the losses are listed down here also. Stray loss, also sometimes we call it as miscellaneous loss. It's losses that is not easily calculated. For example, harmonic losses and also current flow through the core. So mechanical loss divided into 2, rotational and friction and windage. Core loss, sometimes we call it as iron loss as well. Okay. And then, okay, stated here PSCL, stated copper loss, PRCL, rotor copper loss. So those are the losses. Okay. 5 losses. So if P in, you minus all the 5 losses, you will get P out. Okay, P in minus PSCL, P core, PRCL, P max loss, P stray loss, you will get P out. Okay, but if your P in minus these 2 loss only, okay, equal to certain amount of power, right? So that amount of power is your PI gap. For example, this is 10 kilowatt. So for example, this 1 kilowatt, 1 kilowatt, 1 kilowatt. This is 1 kilowatt, 1 kilowatt. So your output will be 10 minus 1 minus 1 minus 1 minus 1 kilowatt. So your output will be 5 kilowatt only. Okay, but at this point, PI gap 10 minus 1K minus 1K, you will get 8 kilowatt. So PI gap equal to 8 kilowatt. Okay, then P converted is here after you minus PI gap with PRCL. So let's say 8 kilo minus 1 kilo, you will get 7 kilowatt. Then to get PR, you can also use P converted just now. 7 minus 1K minus 1K, you will still get 5 kilowatt as the output. Okay, that's how you read and use the plus minus. Okay, you can also read it from the back. For example, P out, you plus Malay, you take back the losses, P out plus 1K plus 1K, 5K plus 1 plus 1, you'll get 7K. So same goes for the other losses. Okay, it's just that. Okay, now what I want to explain is on the losses done. So P in. The input power, V phase, I phase, cos theta. So sorry, V phase, I1 phase. Which I1? We have 3 I. I1, I0, I2. So you use I1 phase. Okay, just the magnitude. Why? Because we are only calculating real power. Real power has no angle. Cos theta. Where do we have this theta from? Theta equal to angle of VT phase minus angle of I1 phase. So angle of I1 phase is here. Angle of VT phase is always assumed as 0. Okay. So 0 minus angle of I1 phase. Done for P in. That is for electrical power. Okay. So output power is mechanical. So formula equal to load torque times omega m. Okay. Load torque times angular speed of the motor. Just now you have motor speed in RPM. You can convert it into angular speed of the motor in radian per second. Okay. Okay. What else? Okay. PI gap also has formula induced torque times synchronized angular synchronized speed. Sama juga. And as you may convert it into omega s in RPM, you will get in radian per second. P converted also equal to induced torque but multiply with omega m. Okay. Also, PI gap has other formula that is this one. Okay. Where do we have this? So this is air gap resistance. So the current that flow through it is I2 phase. So I2 phase squared times R2 over S, you will get PI gap as well. Okay, two formulas for PI gap. Alright, for P converter also has the second formula 1 minus S PI gap. Okay, this has the expression, but I think it's sufficient for you to know the formula. Okay. Okay, I think we're done. Okay, just few notes. Air gap power is also called as rotor input power, RIP. Okay, P converted also has few names such as converted power, developed power, or mechanical developed power. The keyword is converted and developed. Okay. Input power, output power. Okay. As for the torque, okay, we have induced torque here. Induced torque, but this one omega S, omega M. Induced torque is also called as air gap torque. Okay. Induced torque and air gap torque is the same thing. And then at the output we have load torque, or sometimes we call as output torque. So sometimes if there is question asking for torque, for example load torque, just divide P out over omega M. And you will get your torque in Newton meter. Okay, so just for your information, 1 horsepower equal to 746 watt. Because sometimes, for example, the question give P out is 2 HP. So when you need to calculate, you must convert it into watt. Okay, because the other losses or power are all in watt. So you need to convert 2 HP. So 2 times 746, you'll get your power in watt. Okay, as for the performance for induction machine, usually we will be asked to calculate power based on the power flow diagram, and also calculate current based on the equivalent circuit. And last one is to calculate efficiency. Efficiency equal to P out over P in times 100. From where do we get P out and P in? If you can use the formula, go ahead, use the formula. But if you cannot use the formula, then you need to use the plus minus lah. For example, if you have PI gap and you have these two losses, you can find P in. PI gap, you plus back the two losses, plus tadi just now 8K plus 1K plus 1K, you get 10K as your P in. You play around with the power flow diagram to get the power, either for P out or P in times 100, then you'll get your efficiency. As for the torque, if your speed is in RPM, So you can use this formula to directly get the torque. But my advice, convert the speed in omega first, in angular first, omega S omega M. Then straight away use P air gap over omega S or P converted over omega M, or P out over omega M to get the torque. Okay, so 3 important part: the equivalent circuit, the way to calculate the current, the power flow diagram, how to plus and minus, and also all the related formulas, and the multiple names of the power, and last one, efficiency. So that's all for the lecture part, the explanation on the slide. Okay, but as for the examples, that will be based on the tutorial in the tutorial video. Okay, so that's all. Thank you.